All right, good morning. This lesson is for my Honors Integrated 1 class. I'm not really doing a lesson today. Today is April 30th. We finished Module 22. Mr. Nguyen made a quiz that I want you guys to take Friday at 2:30. Let's just take it, see how we do. I don't know how I'm going to grade it, but if you don't take it, I can't grade it. So let's make sure we take it. Grades can't hurt. Assignments can't hurt grades in this time of year, so I have to figure out how to apply that. And I'm going to enter in your quiz from last time, and again, it can't hurt your grades, so I have to be careful how I do that. So I do encourage you to take the quiz tomorrow at 2:30. It'll be on Module 22, and I will talk about what's in this module. But I got a question from one of you about two specific homework problems, and just like in the classroom, I hid my rag from myself, and I don't have my rag, so there it is. I found it. All right, sorry about that. All right. So I'm going to go over two questions that I was asked about, number 29 and number 30 from the book for 22.3. Number 29, let me read you the directions. It says that justify reasoning to show that an obtuse triangle ABC measure angle A is less than the measure angle B. The auxiliary line segment CD is perpendicular to AB, creates a right triangle ADC and BDC. Describe how you would use the Pythagorean theorem to prove that BC, the length of BC is less than the length of AC. Alright. So they want us to take this obtuse triangle, extend aside, drop aside, make a right triangle. I've made two right triangles. Right? This little guy and the bigger guy. And they want us to use the Pythagorean theorem to argue that this length is longer than this length. Okay? So what I did was I wrote the Pythagorean theorem for both right triangles. The length AD squared, the length DC squared equals the length AC squared. So the larger right triangle is this equation. Okay. The smaller right triangle is this equation. All right. So I wrote the two equations, and again, I want to show that hypotenuse is longer than that one. I really added a lot to this picture. All right. So it's a pretty simple argument to make, I think. So they're telling you that the problem involves the Pythagorean theorem. Write the Pythagorean theorem. And so I did that. And I noticed that both equations have something in common. They have that guy in common. So to me, that's how I'm going to make my argument. I'm going to make my argument through this length squared. And so I'm going to take my equation from my smaller right triangle, and I'm going to subtract b squared to both sides, so I get the following. The length of DC squared is equal to the length of BC squared minus the length of BD squared. And the reason why I did that is I want to take this value of length of DC squared and plug it in here into my other equation. So now I have the length of AD squared plus the length of it's not DC squared, it's now this BC squared minus the length of BD squared, and that's equal to the length of AC squared. Alright, so I replace this DC squared with BC squared minus BD squared. Now I want to focus on two things. I want to talk about this length right here. Okay? I think we can understand the fact that this from A to D is longer from B to D. Okay? Because A to D is longer than B to D. So if I take this length and I subtract away a smaller length, I'm going to be left with a positive number, right? So here I am, I'm left with the idea of length of BC squared plus some number. We don't know exactly what it is, but we know it's a positive number, and that's equal to the length of AC squared. So right here, I've basically finished my argument, because remember, I want to argue that this is longer than this. Okay. So if I square my length of BC, I have to add a number to it. And I have to add a number to it so it's now equal to the length of AC squared. This little number that I have to add to that length right here, this tells me that this must be longer than this. Okay, so that's how we would answer number 29. Again, it's a thinking problem. Number 30. I was trying to go through this problem and figure out what the point of it was. And I think that they just kind of got lost chasing their tail in this problem, because it's the problem becomes circular. I really don't see what this is about. So let's see here. So triangle DEF, the large triangle, is acute. Smaller than 90 degrees, smaller than 90 degrees, smaller than 90 degrees. 90 degrees. Angle D is smaller than angle E. So angle E is larger than angle D. Alright, what that means is this side must be longer than that side by a triangle inequality. That's what we want to argue, that EF is shorter than DF. EF is shorter because it's opposite a smaller angle. Alright, I don't get the whole point of this circular argument, but anyways, they add this section, which, okay, I've made an isosceles triangle, so now this angle is the same as that angle. Since this angle was acute, that means that angle must be acute. Okay, so this angle is acute, which is less than 90 degrees, which means I need more than a 90 degree angle to have these two angles add up to 180 degrees. Which means this is an obtuse angle, and in this little triangle, this guy is the biggest angle, so that's the largest side. Which means this side is shorter than that side, because this angle is acute by the beginning of the problem. So an acute angle makes a shorter side than the obtuse angle. So this side is longer than this side. This side is the same as that. I mean, again, it's a goofy problem. I don't know what they're trying to get out of it. You could have answered it right off the bat. So if you're struggling with 30, don't really worry about it. But again, we'll take a quiz on Friday at 2:30. Okay, so let's do our best on that. You'll see that come up, and again, I hope everyone's doing okay out there. Just take a couple minutes, look over the videos. I think that should be enough for you guys to be able to do okay on the test. And I don't know if I can really call it a test, but anyways, I hope you guys are having a good day. I will post the next video Monday or Tuesday next week. Have a good weekend. And make sure we take the attendance quiz as well. Have a good day, everybody.